In this video, we're going to start to talk about section 11.3 and discuss a new important value called the coefficient of determination. If we take a look here at example 1, we have this car data that we've been looking at for the past couple sections. And we can see that if we just quickly review the information here, that we have 10 different cars, each of which is getting a certain number of miles per gallon. And we might want to ask the question, why is it exactly that different cars are getting different miles per gallon? And one obvious answer is that, well, the cars have different weights. So weights of the cars might actually be affecting why a certain car gets miles per gallon that it does. So heavier cars may be getting a lower amount of miles per gallon and a lighter car is getting a higher amount. But we might start to realize, if we think about it briefly, that that's not necessarily the only reason why cars might end up with different miles per gallon. In fact, if we think about it for a bit, we could probably come up with a huge list of different factors that might affect why different cars get different miles per gallon. Just a couple things that I can think of here off the top of my head would be something like maybe the type of engine that the car actually has. That could possibly affect the miles per gallon. Maybe I could think about something like the tire pressure for the car. Okay, what's the tire pressure currently set at? How is that going to affect things? Maybe I could think about like the driving habits of the driver. Is this a person who's going to be, slamming on the gas and then slamming on the brake, going 0 to 60 in between stop signs in a subdivision? That's not going to be very fuel efficient. I could think about like where you drive. Are you doing city driving? Are you doing highway driving? All of these things can start to affect miles per gallon. And in fact, we could probably, as I mentioned before, come up with even more items to continue to add to this list. So the question that we really have is that if we can kind of divvy up responsibility for highway miles per gallon to these different factors, which one of these might be the most responsible for affecting the miles per gallon? And as I state down here, which of these factors then would maybe best explain the fluctuation or the changes in this? Well, to help answer this question, we are going to talk about what we call the coefficient of determination, which is listed here with the symbol of r squared. Now, this value of r squared measures a percentage of the sample variation or fluctuation in the y. So it's looking at the miles per gallon, and this r squared is going to measure the fluctuations in those y values and try to figure out what percentage of that fluctuation can be explained by the line of best fit with our given x variable being weight of a car. If I was to go back and remeasure these cars and maybe do something like tire pressure as my x, I could calculate a different r squared. So r squareds are again measuring how much does y change and how responsible is a specific x for that change. Okay. Now, if we take a look here, we'll see that again the value of r squared is going to be a number from 0 to 1 because it's going to represent a percentage. R itself was a value we talked about a couple sections ago, and it was not a percentage. We kind of thought about it as like a score, but r squared is a percentage. So let's take a look down here at example number 2. I want to compute the coefficient of determination for the car data that's up above and interpret the value. Okay, so the first thing that I would need to do in order to do this is I'd have to click on the Stat button, go to Edit, and I'd have to make sure that all of my data is entered into lists. Now, as you can see here, I've already gone ahead and entered in the data that I need for the cars here, and I've actually entered the data for all the rest of the problems that we'll do in this section as well. I'd ask you right now to go ahead and pause the video, enter your numbers, and then you can hit play the video again to see me work through this question. Okay, so if I have all the information now typed into the calculator, what I can do is I can click on my Stat button and go over to Tests, and I can go to my linreg t-test that we used previously to find the value of r. In this test, I just have to make sure that I have the right lists selected, and I don't actually have to care about any of the other information that's listed in here. It doesn't matter what this line says, it doesn't matter about the reg EQ, that's completely irrelevant. But if I hit calculate and I scroll down, I'll notice that near the value of r is the value of r squared. And this right now is the value of 0.6693. So I'm going to go over here and I'm going to just record that value down. My value of r squared was approximately 0.6693. As a percentage, that would be 66.93%. So that's the percentage that I end up with. But of course, I want to interpret this value and not just write it down. So what does this value mean? Well, I would interpret this by saying that this means that about 66.93% of the fluctuation in the highway miles per gallon can be explained by the weight of the cars. So again, the Y values up here were changing, and how responsible is weight for those changes? Well, it's responsible for about 66.93% of the change, at least as far as we can tell. Now, of course, that means that if I think about all of the change, there's still some percentage that I'm missing. So as kind of like an extra amount or an extra little side note, I could note that this would mean that about 33.07%, notice I get this number from doing 100% minus this percentage. This is the leftover percentage. But I can say that this much, this percentage of the fluctuation in the highway miles per gallon can be explained by other factors. And these other factors might be things like the list that we started writing up above. Maybe the remaining 33-ish% has to get divvied up between types of engine and where someone drives and how they drive and things like that. So this is how I would actually go ahead and do one of these interpretations.